Thank you for joining this lesson. We're going to study some physics. We are told that the figure below shows two waveforms representing the same wave motion. So we can see the first one is having displacement in meters and distance also in meters. Therefore, from this first wave, we can extract the wavelength of the wave because we can see there is a distance along the x-axis. While on the other one, we have displacement, the vertical displacement of particles, and on this side, we have a time in seconds, which means the factor which can be read from this wave is the frequency, because from time we can read periodic time. Then from the first one with distance, we can read the wavelength. Determine the velocity of the wave. Determine the velocity of the wave. We should know that velocity is usually given by frequency times wavelength, lambda. Therefore, we can first get frequency, which is given by 1 out of t, the reciprocal of periodic time. Therefore, we can extract the periodic time first from the second wave. Time t, period, is given by the time in one complete oscillation. Therefore, we can see from this kind of a wave, from 0, so one wave is at this point. So this means we have 0.015. This has to be 0.030, so that we go to 0.045. Then when we add 0.015, then we go to 0.60 at this point, 0.06. So at this point we have 0.06 according to the scale. So which means from 0 to 0.06, then periodic time is 0.06, and this means now frequency is going to be the reciprocal of 0.06. Let me get the reciprocal from a calc. 0.06 reciprocal. This is giving me 16.67. It should be hertz, the SI unit of frequency. From the other one, let me get the lambda wavelength. So this is half a wavelength, and we are moving from 0.1 to 0.3. So which means a complete oscillation, because we have in a half oscillation 0.2, then it means in a complete oscillation, or rather one cycle, I'm going to have 0.4 seconds. Therefore, if this is period t now, period t, excuse me, this is not period. Remember, this is distance. Therefore, these are meters, and it is going to be our wavelength. So wavelength is the length in one oscillation. We can see in a half oscillation, we have 0.2 meters. So in a complete oscillation, then we shall have 0.4 meters. So we can now get to our velocity, which is given by f lambda. This is going to be 0.4 times 16.67. So when I multiply 0.4, I'm getting 6.66 recurring. So we can have 667 meters per second as the velocity of the wave.